If you ever studied the theory of general relativity, you might heard the phrase gravity is an illusion, or gravity is not a force, or gravity is kind of a fictitious force. Well, I will talk about that right now. Well, imagine you are inside a car and you accelerate forward. You will feel a force that pushes you back to the back. That's the same force that push the ground is pushing on your feet right now. You know what I mean. Well, if you don't know, I will explain further. So, when your car accelerates, there's a net force that forward because F equal ma, it makes your car accelerate forward, right? But the thing that F equal ma only apply to non-inertial frame. If you inside your car is non-inertial frame, so you have to believe your car is stationary by assuming there's a force field that pushes the rest of the universe backward. And that force field will cancel the force from your car engine generated. And the result is the net force, it will be zero, so your car do not move. And the rest of the universe will accelerate. And this is where it gets absurd. Now, you will see people accelerate at the same time you feel the force, but if you think more clearly, it means that massive objects fall away like the moon, the sun, even the galaxy, the star, the end of the universe will experience that fall. And it do so instantaneously. It's like the force switch on everywhere in the universe. How can that be possible? Now, Einstein proved that everything falls at the same rate no matter of the mass, as long as the mass is very small compared to the big mass in the Newton equation. So that's called the equivalent principle. But so when you are in free fall, you feel no force, or you feel no inertia, you feel weightless. So that is the same. If you think about the definition of the fictitious force, it is the force that's not real or can be transformed away using a coordinate transformation, as long as you transform it to an appropriate coordinate. For example, if you transform your coordinate away to the people standing on the ground, then that force will disappear. And it's kind of true locally for gravity. I say locally because gravity can change strength depend on the separation. That's what tidal force means. The acceleration due to gravity only varies at one point or small region around it. For very large object and very massive, it can tear like tidal forces. So that's first sign gravity is kind of more real than fictitious force. But let's go deeper. This is very interesting. It's mind-blowing because I have studied special relativity and I realized that I can use this reasoning. That's it, causality or cause and effect. So let's talk about special relativity a little bit. As it turns out, in special relativity, it's possible to travel faster than light as long as your action, your situation do not have any causal relationship. What do I mean? Just like the example where I say that the star at the end of the universe will feel the fictitious force instantaneously, that's ridiculous, that's faster than light. There's another way to think about it. So the Earth is spinning, right? It's rotating, but 24 hours, one evolution. But if you imagine you are putting your coordinate to make the Earth standing still, well, the sky will be moving. That's what sun sign and sunset mean. If you measure the distance to the star and assume it's what the radius, and you measure the angular velocity, the velocity of the star, it can be faster than light. And this is the same problem with the laser dot experiment problem. When you imagine you have a very strong laser that you could shine on the moon, as you rotate your laser pointer very strong, the dot can move faster than light. Because the dot isn't exist, the dot is a physical object. It do not have any causal relationship with the moon or the line around it. The only thing that had causal relationship is the moon and the photon flying up your laser pointer. So it's always limited how you can affect the moon physically. If you shine very strong laser towards Sirius, say a star 8 light years away, it will take 8 years for the star to be affected. So that's the problem. Wait a minute, gravitational wave like your detector. Wait, gravitational field, even in Newton framework, you propagate at the speed of light. It means it has some causal relationship. It respects causality. So if you have two neutron stars orbiting and they came to each other, they will generate very strong gravitational wave because they accelerate very fast, and also they're very heavy. And that propagation of space-time curvature to kind of respect causality. As it turned out, in general relativity, the Newton gravitational field doesn't exist, but it's replaced by what's called the curvature tensor. And a tensor is mathematically an object that keeps its meaning invariant. It means the meaning will never change no matter what coordinate system you choose. You cannot remove the tensor away. Imagine a vector on a plane. You rotate a plane, the component of the vector will change, but the length of the vector will stay the same. That's kind of true, because vector is a tensor, but so do scalar and also a higher rank tensor. So now in general relativity, the concept of gravitational field has changed. It's now a Riemann curvature tensor, and that tensor cannot be transformed away. It means it's not exactly equivalent to the situation of physicists for, because the situation of the physicists for, do not respect causality, right? And it also seems to influence the universe instantaneously. So just like the laser dot problem or the rotating sky problem I just talked about, well, it can be removed completely. It means that the tensor can have zero value, which is the vector of the Fetisi field here, but not the Riemann curvature tensor. That this tensor defines gravity depends on the energy and mass, which it has clear causal relationship. So tensor cannot be removed away, unless, like I just talked about, if a tensor like the Fetisi field can be removed away completely, then that is a pseudo tensor. Actually, some vector in physics do that too. It's called angular momentum. If you put your coordinate system side away, the angular momentum can disappear for a moment when a rock is orbiting, the particle orbiting around. That angular momentum can have zero value or component, for example, for a very slight moment. And that's why it's a pseudo tensor, because a tensor cannot do that. That is what it means to be real in mathematics. But the cool thing here is that you don't have to know the math of general relativity or complicated tensor calculus. You just predict that with special relativity. So if something respect causality, it means that thing must be real. And gravity respect causality, but not the Fetisi force. So gravity is indeed real. But why? Because it's not a force or an illusion, just like Fetisi force. That's because the problem with measurement, well, it's very hard to distinguish gravity and acceleration. It is impossible, in fact. It's called the Einstein famous equivalent principle that I should talk about. If you have a gravity accelerometer, if you let it in free fall, it will say 0z until the force hits it, the force from the ground hits it, and puts the force on it, and it will measure non-zero value. That's because it does not feel gravity, it only feels the contact force that puts it. And the same reason for astronauts on space station ISS feel no way. Thanks for watching.